Okay, thanks everyone. It's Qiaosheng Chen, and I'm pleased to be representing our work enhancing dataset search with compact snippets, which is a collaborative effort with Jiageng, Chen, Xiao, Zhou, and Gong, Cheng. We are all from Nanjing University State K Laboratory for Novel Software Technology. And in the next 15 minutes, I will walk you through our pioneering approach to content-based dataset search over multi-format datasets, focusing on our novel methods for extracting query-based data snippets that enhance both data ranking and result presentation. First, about the background, as more and more datasets are released on the internet, the task of dataset search has become more and more important. The specialized IR task has received increasing attention in both academy and industry. One of the most representative dataset search systems is Google Dataset Search. And here is a screenshot of Google Dataset Search with the query word camp goals. This interface allows users to search for datasets relevant to their query. The results include various datasets that contains information about what camp goes, each with their descriptions and other metadata. While systems like Google Dataset Search are highly useful, they are primarily metadata-based. This means that they rely heavily on the metadata such as titles, descriptions provided for each dataset. However, this approach may struggle to find datasets whose content matches the query with the metadata is incomplete or inaccurate. Additionally, these systems do not virtually display the dataset content in the search results, which can make it difficult to which make it difficult for users to determine the relevance of a dataset without further investigation. So to address these issues, we propose a novel approach dataset search with query-based data snippets. This approach not only retrieves datasets based on their content, but also extract and present compact relevant data snippets directly in the search results. Our approach enhances both dataset ranking and result presentation, making the search process more effectively and user-friendly. For implementing content-based dataset search, we need to address two significant challenges. First, the magnitude of the data. We may encounter tabular data files with millions of rows or JSON data files with millions of key-value pairs. Handling such large volumes of data effectively and efficiently is a critical challenge. Secondly, the heterogeneity of the data. We may deal with a wide variety of data formats, including textual data such as TXT, PDF, and also tabular data like CSV, key value pair data such as JSON or XML, and additionally, we encounter graph data formats like RDF and OWL. Each of these formats requires different methods for parsing, processing, and extracting relevant information. Our goal is to develop a unified approach that can handle the device nature of this dataset effectively, ensure that the search system remains robust and efficient. Now let's discuss the limitation of existing content-based methods. In response to the magnitude challenge, existing methods often extract small fixed data samples from extensive data, which may not represent the dataset accurately. Fixed data samples expose shorts when matching with a wide range of queries, thus offering limited assistance in enhancing search accuracy. Moreover, these methods tend to focus on single-format data, such as table-only or graph-only datasets, limiting their applicability across diverse data formats. In contrast, our work extracts query-based data snippets and for multi-format datasets in a unified manner, ensuring that the snippets are both relevant to the query and representative of the data content. Furthermore, our work enhances dataset search by not only improve ranking of search results, but also provide informative and user-friendly presentation of these results. As illustrated in this figure, our content-based data search with data snippets incorporative data snippets extraction module into the common retrieval, re-ranking, and presentation pipeline. After retrieving the candidate datasets, we will extract data snippets to serve a dual purpose. The first is to provide query-based data snippets to enhance data ranking, and the second is to supply query-based compact data snippets for results presentation. For these two purposes, we designed CDS method, which is a novel query-based compact dataset snippet extraction method for multi-format data, which is our co-contribution. This figure outlines our methods, including offline and online process. The offline process in blue comprises two main components, which is graph-based unification and dense decoding. Firstly, the graph-based unification component transforms raw data in various formats into a unified graph representation called a data graph, and which is connecting entities associated with attributes. This step uses predefined mapping rules for transforming. Subsequently, the textual description of entities and attributes are encoded by a dense encoder into text embeddings. These embeddings vectors are then indexed to facilitate efficient online retrieval. The online process in green composes three main components, which are subgraph extraction, attribute selection, and revision. For a given query and the raw data files in a dataset, the first step is obtaining a group of relevant entities for each query with support of the entity index. Subsequently, a compact subgraph is extracted to cover the most groups of relevant entities. This task can be formulated as the diameter-bounded max coverage group standard tree problem. Following this, attribute selection based on query relevance is performed to filter the attributes with the support of attribute index. This results in a subgraph with selected attributes called unified data snippets, which can be linearized to generate pseudo documents, thereby enhancing content-based dataset re-ranking. And meanwhile, it can be reverted to the original format of the raw data files, facilitating results presentation. To evaluate the performance of our approach for enhancing data accuracy, we conducted dataset re-ranking experiments on two ad hoc dataset retrieval test collections. The first is NTCIR, which contains datasets in various formats, and the second is a CODA, which is exclusively composed of RDF datasets. As illustrated in the first table, our data snippets enhance ranking consistently and significantly improve the results of first stage retrieval. The best performing model is BGE. Secondly, comparing with baselines, our approach exhibit the superior performance compared to the state-of-the-art methods on both collections. For the NDCR is Modbot and the is ANC, and for Conda is DR2. To evaluate the effectiveness of data snippets extracted by our CDS methods, we perform an abortion study. We either use the only metadata in re-ranking or use snippets extracted by a baseline method called EluSnip. As illustrated in the table, our CDS noticeably outperform its two variants in almost all the settings. As for the running time of our CDS methods, the online processing time of our data snippets extraction methods for each data file in two test collections is shown in this figure. The distribution shows that over 80% of data files are processed within 500 milliseconds, and with over 95% completed in 1 second. Which shows an acceptable level of time latency for online queries. To evaluate the usefulness of our compact data snippets in helping users to assess the relevance of datasets to a query during result presentation, we conduct a user study that simulates a real-world dataset search scenario. The results of our user study investigates the accuracy of users' relevance judgment across various methods for dataset presentation. Compared with only providing metadata to users, adding data snippets can improve the accuracy of user judgments, and our CDS methods also show better improvement efforts compared with the baseline method. Then let's look at an example compact data snippet in JSON format. The query is hell weight, while the title and description of this dataset lack relevant textual descriptions, and our data snippet contains the relevant case. Finally, to conclude our work, it is a pioneer to utilize heterogeneous web data content for dataset search, and its key technique is unification and snippet extraction method, which address magnitude and heterogeneity in structured data. Its key features are query relevance and compactness. As for the limitations and future work, one key limitation is that our graph-based unification relies on predefined mapping rules. It can be inflexible and may not adapt well to diverse or involving datasets. To address this, we are exploring the development of structure-aware long-context large language models, which can dynamically understand and unify diverse data structure without relying heavily on predefined rules. Another limitation is handling large-scale data graphs, which can contain billions of triples. This poses significant storage and computation challenges. So that more efficient graph search algorithms to manage these large-scale data graphs more effectively is needed. Okay, that's all. Thanks for your attention.